Welcome today. We've got a great webinar ahead for all of you, best practices for supporting Wi-Fi clients. Again, my name is Don Cook. I'm the Chief Marketing Officer here at 7 Signal. With me today is Heather Dremel, our Digital Marketing Manager, and of course, Jim Vajda, CWNE 183, and our Chief Wireless Officer. And Jim, I'm gonna hand the controls over to you, and you're gonna lead us in discussion again today.
Perfect. Well, we're going to talk Wi-Fi clients today. One of my favorite topics here at 7 Signal. First, a little bit about me. If you don't know me, like Don mentioned, I'm our Chief Wireless Officer and a CWNE. I just renewed my CWNE and I just renewed my CCNP, so those are good for another couple of years. Yep, but backstory is as a wireless network engineer in different enterprise verticals. And you can follow me on Twitter. I've got a blog about Wi-Fi, and I'm also on the ham radio bands on 2 meters and 70 centimeters at Kilo Echo 8, Oscar Kilo Victor. Today's topic, though, is best practices for supporting Wi-Fi clients. And first, we're going to talk about kind of understanding why they're so important and the role they play in the Wi-Fi network. An important thing to understand about a Wi-Fi network is it's really just a network of radios, right? You've got AP radios, you've got client radios. They're all using the same protocol. They're all transmitting and receiving. But the client radios make up the bulk of the network. So even though a different group outside of the network team may be responsible for them, they're a huge part of your wireless network, and they need a lot of attention. So that could be with 1,000 APs in the network, you could have 20,000 clients, maybe a lot more in a stadium environment, for example. And when we talk about clients and APs, you'll hear me use the term station. That's just a radio station. It's either a client or an AP, anything with a Wi-Fi radio that's transmitting or receiving in the 802.11 standard just gets called a station. So I'll use that term a little bit today. And they all have an impact on overall performance. So one of the myths I want to discard is that the way Wi-Fi works essentially is that you've got this access point in the center, and it's transmitting a signal that all the clients have to receive. And if the clients receive the signal loud enough, you've got a good Wi-Fi network. That's partly true. The access point is transmitting and the clients are receiving, just like we do with AM/FM radio, for example. You've got a big transmitter up on a hill somewhere, and you've got radios in the region that are receiving its signal. But Wi-Fi is actually much more complex than that. The reality looks more like this. All the radios participating in the network have to transmit and receive, and they all have to be able to receive each other. So when you look at it this way, you can sort of see that actually we think about the AP being so central to performance, but the client radios are just as critical and play just as an important role. So, you know, one way to think about that is just to say a station is a station. It's an AP or it's a client, it doesn't matter. But we spend a lot of time really focusing on our APs, making sure they have stable code. They're all running the same code. Standardizing on hardware. You know, we usually only want to run a single AP model inside, you know, one building, for example. But the majority of our wireless network, those clients, we don't have anything like that. So just imagine if all your APs, if in the same wireless network you had APs from Cisco and Aruba and Extreme and Meraki and Ruckus and Mist and so on. all in the same network. And they were all different models, and they were all different code levels. It would be an enormous disaster of a Wi-Fi network. But that's kind of the status quo for our clients. We don't have standardized hardware. We're not standardized on vendors. And we probably have a whole variety of different drivers and operating systems on those machines that are affecting their Wi-Fi performance. So that's one of the reasons why, clients deserve more attention than they get. One way to think about this is that, we can think of, I think two-way radio actually is a really good analogy for Wi-Fi because the channel access is the same. You have to wait for the channel to be clear before you can transmit. Otherwise, you'll transmit on top of someone else and it'll just be a garbled mess. You also can't hear your transmission while you're transmitting. But to take that a step further, in a lot of enterprise networks, our access points are like these really nice Motorola two-way radios. These are ruggedized, they've got really high quality components. They're tested in extreme environments. This is a radio that a first responder might use. You could put this in environments where life and death matters, and the performance of this radio has to work. That's kind of what our access points are often like. High quality components, well tested, well engineered, but then the clients on the enterprise networks are not built to the same standard at all. They're more like these cheap children's toys of two-way radios, built to be super cheap, lowest quality components because they're cheaper, poor batteries, just undependable. You wouldn't use one of these in a really important environment where communication was really critical. And yet, a lot of the clients on our Wi-Fi network are unfortunately built with similar design goals as these clients. So it's a problem. So one more analogy about Wi-Fi, and then we'll kind of really get into some details. I like to think about Wi-Fi networks as behaving a little bit like orchestras. So you can imagine everybody's playing in sync. They're following, the beat and reading their music, and it sounds great. But what if just one of these violin players was playing out of tune? Their violin was out of tune, or maybe they just played the wrong notes. The whole piece would be totally ruined. But think about it. There's 100 players, we'll say, in this orchestra. And only one is making mistakes. So 99% of everything is perfect. It's still the worst music you've ever heard because of that one violin playing out of tune. Everything just kind of falls apart. And Wi-Fi is similar to that. If we're not addressing all the different factors that impact performance, it kind of falls apart. Now, the protocol is robust. It will keep working. You can get data back and forth when some things aren't right. Just like this orchestra can keep playing if somebody's making mistakes. But it wouldn't be a very memorable performance, and there'd be obvious problems that should be addressed to improve it. So if we think about Wi-Fi this way, there's different sections of the orchestra that are really important to the music of Wi-Fi performance. There's wireless design, which is critical. You have to have a good RF design. You have to have the infrastructure, good APs, the right antennas, the back-end network services that support Wi-Fi, All that has to be addressed. The spectrum has to be addressed. We're using unlicensed spectrum, so we need to make sure it's clean and use channels that are unoccupied and free of noise. But we also have to address the clients. These are the most overlooked instruments in the orchestra. And even if we take care of these other three sections and they're doing great, our clients can show up and really, cause a lot of havoc on the Wi-Fi network. So I want to encourage everyone to take extra care in considering the clients that make up, the bulk of the Wi-Fi network. So let's talk about some specifics now. Let's get into some more technical stuff about Wi-Fi clients. The things that really impact their performance. There are those layer 1 PHY factors, the supported PHYs, the bands, the spatial streams, the quality of the components, the radio sensitivity, the antennas in use and their design. There's always some compromise about antenna design. Not a lot of clients that have external antennas that are, pointed straight up, right? There's proprietary things. There's a lot of proprietary things in clients that affect their Wi-Fi performance. The roaming algorithm is a big one, and we'll talk more about that. How they handle power save operation. Some clients don't do that very well. The way they choose data rates, their dynamic rate shifting algorithm. These are all black boxes, right? But they're important to their performance. And then there's kind of just this general bucket of stability and interoperability things. Like those cheap children's toys of two-way radios, you don't really expect them to kind of just work all the time and be rugged and reliable and sort of set it and forget it. They're, they have serious quality issues. They have buggy code. They may not be able to maintain a connection for very long or in certain conditions that you might have on your enterprise network. So a couple things to look at when you're testing clients. These are 5 items that I think are really valuable that usually, or in a lot of cases, don't show up on the spec sheet of the client that you're evaluating, but have a big impact on their performance in enterprise networks. Number 1, the band and channel support. Do they support 5 gigahertz? You really got to have that if there's any latency or throughput or performance considerations. If there's a human using that, expecting kind of back and forth interaction with an application, it really should be on 5 gigahertz and not 2.4 only. And think about 6 gigahertz too. There's plenty of 6 gigahertz clients out there now, and you may not have a 6 gigahertz WLAN yet, but there's no reason if that's not in your future to wait to buy clients that have that support. Within the 5 gigahertz band though, you want to know what do they also support the DFS channels and what subset of those are supported. If you bring clients in that don't support channels, say 120, 124, and 128, then you can't use those in your design. So you got to stay on top of that. Usually that's not published in spec sheets. Sometimes it is. Security methods. We're supposed to be using enterprise security in our enterprise Wi-Fi networks. So we want to make sure clients support WPA2 or WPA3 enterprise. We want to specifically know what EAP methods they support. We're probably using PEEP or EAP TLS or EAP TTLS, or maybe a combination of those. But it's an important thing to check to make sure that we don't need to, we don't have some incompatibility issue there. What's often overlooked though, in my experience and really important, is the security provisioning of these devices. So if you're bringing on 1,000 new clients from a vendor, and you need to onboard them onto your 802.1x network with individualized EAP-TLS certificates. How do you get those certs installed on those devices? Does the vendor offer software that helps you do that in bulk? Is it compatible with, say, Microsoft Active Directory certificate services, or whatever you're using as a certificate authority? That's actually really critical, because a lot of times this kind of falls apart because it's just too hard to get these get security provisioned properly on all these devices when we're doing 802.1x. And so we kind of fall back to just, we'll use WPA2 personal and just use a pre-shared key on all of them. So look into that. Roaming performance, so huge problem for Wi-Fi clients and enterprise networks. A lot of them are really sticky clients that don't roam well. You got to think about the use case for the client. If it's going to sit on a desk and never move, then its roaming performance doesn't really matter. If it's a tablet that someone's looking at as they walk down the hall and it's streaming a video call, it's got to roam flawlessly, and that's rarely documented. And even when it is documented, you need to verify it in your network. Sometimes what's published doesn't match what you observe in the real world, in my experience, as far as roaming performance goes. Roaming amendments, again, for those clients that are mobile, support for 802.11k VNR is really helpful to speed up roaming and have as little packet loss as possible during AP discovery, and also once that roam has begun, we want to make that as fast as possible. And then connection stability, another thing to look at here. Can this client just stay connected without just kind of randomly dropping packets or disassociating and reassociating, or just flaking out and totally restarting its network stack, or so on and so forth? You can't take that for granted, unfortunately, with Wi-Fi clients. So that's, a little bit longer term test, but definitely worth doing, because you'll find those just strange oddities where, yeah, it was connected yesterday and I showed up today and it was not connected for no reason. Nothing changed. It just disconnected itself. So let's talk about some classes of devices. When we have enterprise managed devices, so the devices the enterprise owns or has control over, there's a lot you can do if you're on the network team or have some responsibility for the Wi-Fi network, from a process perspective, to kind of fend off some of the worst problems that Wi-Fi clients can cause on the Wi-Fi network. But it's really important just to get engaged, talk to the device and desktop groups, maybe even do a lunch and learn. Hey, let's talk about Wi-Fi. I want to talk about how the clients you guys manage are 90% of our Wi-Fi network, and this is how they're interacting with APs and each other. That can be eye-opening. I think it's really valuable to get embedded in the purchasing process with the procurement department in an organization. They're the people that are writing the checks to the vendors that buy the new clients that show up on your network. And at least there, that's kind of like a choke point where all these purchases are coming through. So if you're not aware of a project before it gets to procurement, you should know then. And at least you can say, hey, I didn't get to evaluate this. I don't know if it's going to work well or not, or I've evaluated it and here's my take on it before a purchasing process is made. really important. And part of that is being able to require and do demos and POCs of new clients on your Wi-Fi network before purchasing. It's really required. It's really important. There's just too much about their performance that's really unknown and can go wrong. And again, isn't really documented on spec sheets and data sheets that you want to be able to see. So, you know, think about it like this. The barbarians are at the gates. A lot of metaphors in this one, Don. And you need a strong defense to keep those clients at bay as much as possible. So get involved early in projects that touch the Wi-Fi network whenever possible. Whenever there's interest in new clients, if it's the desktop group, if it's clinical engineering in a hospital, if it's another group, if it's a group that's not even within IT, everybody's interested in doing projects that involve wireless networking. And you want to get plugged into those. You want to have some ears in those projects, and you want to go in and say, this sounds like a great project. We've got a great Wi-Fi network that can probably support it. We just need to verify that the device that you're interested in actually works well on our network. And then you can go through the whole spiel and use the metaphors I just gave you if you want. But you're so much better off going to a few extra meetings early in this process than finding out about new clients late in this process. You don't want to find out that there's a new client on your Wi-Fi network through getting a support call about your Wi-Fi network getting broken because some new client just showed up and it doesn't work. Because that's where the blame goes, right? Unless you're actively educating your organization, they think, you know, they have that myth in their head about an AP transmitting a signal and that's all that matters. And they will blame your Wi-Fi infrastructure for client-side Wi-Fi issues. So get ahead of it. One of the things that can really benefit from, that can come out of that client testing, is developing some standardized configurations, some, you know, blessed configurations. You've tested a client, say we'll talk about like a Windows laptop. It's got this adapter, this driver version, and we configure the advanced driver settings this way, document all that, and say this is a blessed configuration and your clients need to be one of these for good performance. And then share that with the desktop, with help desk. You know, one of the great, you know, this isn't being proactive, but it's saving you time. If the help desk, whenever they get a support call involving Wi-Fi, has a checklist to go down and say, okay, this laptop's got this adapter, okay. Oh, the driver version's out of date. It needs to have this driver version. I'll go install that and let me tweak these advanced driver settings, and we will close this ticket and say, yeah, just let us know if it starts happening again. That is really going to save you a lot of time, because in a lot of organizations, that ticket would just get escalated to the network team, who would look at the AP infrastructure, the wireless infrastructure, and say, the Wi-Fi's fine. I don't really have anything for you here. Or they'd have to go out and look at the client and try and find it and do that troubleshooting that could have been done earlier. So that can save you a lot of time, and there's a lot that can be changed. Like there's a lot of little nerd knobs, particularly with Windows clients, that we can turn to improve Wi-Fi performance. Let's talk about some specific platforms. So with Windows clients, we have a lot of options at our disposal to improve their Wi-Fi performance. First of all, we can update the driver versions of the adapters they're running, and that's really helpful. But I would say, don't go to the PC OEMs for driver updates. Like, don't go to Lenovo and Dell and so on, looking for the latest updates they've got. Go to the websites of the adapter vendors themselves, Intel, Broadcom, Marvell, etc., and get the latest versions they have there to test. They'll be a lot newer, and they'll have a lot of fixes that are that might, really be targeted towards the enterprise. The OEMs are very slow to update drivers in the software they support, whereas the adapter vendors tend to push fixes out much faster. Of course, you want to test that to make sure that that new version of that new driver is going to perform well as well. Look at the advanced driver settings in Windows drivers. Got a link here to what Intel shares. You don't have to write this down. We'll share the slides so you can just grab the link out of the slides. But there are a lot of configuration options for the different adapters out there that can affect their enterprise Wi-Fi performance. We talked about roaming being a big problem. Here's an example of some things you can do on Intel adapters that can improve the roaming performance. One thing you can do is set the preferred band to 5 gigahertz. That's going to bias its roaming algorithm to favor connecting to your 5 gigahertz radios instead of 2.4 gigahertz radios, which is generally a best practice in the enterprise. We can also change the roaming aggressiveness. Now, Intel doesn't say what the different values actually mean, but in my experience, if you crank it up a notch to medium high, you've got roaming. As long as the drivers are pretty stable, most Intel adapters will roam well enough to support things like a Citrix session or real-time applications. So look at those. Windows 10 supports 802.11k VNR. That's not well known, but you can use those features with Windows 10 clients if they have the right adapters. So link there from Microsoft on understanding that, and also a link here on Intel about the adapters that you need and what roaming amendments they support. So the 7265 and everything newer from that should support most of this, but follow that link and see what's possible with what you've got deployed. And one more thing about Windows clients that deserves a special call out. There are, and this has been a problem for a couple years now in the enterprise, but if you've got 802.11ax access points and you've got 802.11ac Intel adapters, those adapters may not be able to connect to those APs because of bugs in their drivers, the client adapter driver, to be more specific. So that's been a big problem. It's led to a lot of people turning 802.11ax off on their APs to get these clients connected. And there's a link to the lowdown on that. So beware of that risk with 802.11ax. So let's move on and talk about enterprise managed Apple clients. So far fewer configuration options here. Actually none, really. It just kind of is what it is. And you hope what you get from iOS and macOS gives you the performance you need. Sometimes operating system updates will include driver updates, and and tweaks to those proprietary algorithms that affect Wi-Fi performance. That's one thing to try if you've got an Apple client that's not behaving well. Apple does publish some information about the roaming performance of their two operating systems. With iOS, it's got a little bit more aggressive roaming algorithm than macOS. But I'd also, just my own personal experience is that particularly macOS really struggles to roam well. And I would be hesitant to put it into an environment where mobility is really important to you. So they publish these specs about how the roaming is supposed to work, but it's, again, something you want to verify in your own environment. Really good reference here, though, is a enterprise best practices for iOS devices and Mac computers on Cisco wireless LAN. White design reference from Cisco and Apple. It really kind of gives you the lowdown on what Wi-Fi design principles and features will enhance the performance of iOS and Mac computers, what you can do on the infrastructure side to help them out. So if you're having issues with these devices, that's a good reference to see if maybe some of those best practices you may be able to implement while also supporting all the other clients that you must support on the network. Let's talk about Android. Android has a big fragmentation problem, and it's really important that you consider each device as being unique. You might have a Samsung tablet with Android 11, and you might have a SpectraLink phone with Android 11. They probably won't behave similarly at all. There's just so much that can be changed. It's an open source operating system, so the vendors do go in and make changes to the OS, and so give them each a thorough evaluation. Some devices, though, particularly those that are targeted at the enterprise for voice over Wi-Fi from Zebra and SpectraLink, should have mentioned ASCOM here too, and others, they will have some configurable Wi-Fi settings that you'll want to tune to best match your environment. And similar to Apple, operating system upgrades may include driver updates and change roaming performance. So have a look at those, and sometimes change security requirements. So if you were, for instance, Android 11, I believe, had an update last year that prevented you from connecting to a 802.1x network without validating the server certificates, which is a good thing, but you want to be aware of those kind of things before they happen and affect your network. Samsung, similar to Apple, has published a roaming algorithm, and they specify a -75 dBm roaming threshold. So you can look at that and decide if that's going to meet your needs as well. And so the last class of device to talk about is this big bucket of BYOD, bring your own device, that a lot of Wi-Fi networks have to deal with. It's hard, right? You can't control the makes, models, adapters, and drivers in use on the network. Everything I just showed you about here's how to fix things and improve things kind of goes out the window a little bit with BYOD. So it's really important that you manage expectations around the organization. Some clients just aren't going to work. It's just not realistic to say any Wi-Fi client is going to work well on our network that comes through the door. They just won't. Some will be better than others, some will be buggy, and you need to make sure that as an organization it's understood that we've done everything we can from an infrastructure perspective, but the clients that walk in the door themselves You know, they might be playing out of tune, and there's nothing we can do about that. I'd also stay away from using voice over Wi-Fi over BYOD. That's just my own opinion there, but without really well controlled and tested clients, you know, voice over Wi-Fi is going to be hard to pull off in an acceptable fashion. One thing you can do is publish some minimum device requirements for your network. A good one is 802.11ac, sometimes called Wi-Fi 5. And it's a good minimum requirement because it requires support for the 5 gigahertz band. 802.11n is a pretty good PHY, but it can come in 2.4 gigahertz only flavors, which you don't want on the enterprise. You can specify WPA2 enterprise as a requirement, and you can put a, you know, you can depending on the organization, you can put something in there in your requirements about how, if you know BYOD, that if you don't meet all of these specifications, then these things we do in our organization will not work or will be unreliable. And then something to consider for that BYOD network is just, can you disable 2.4 gigahertz entirely? We can't change how the clients roam to make them prefer 5 gigahertz. So can we just turn it off and say we only support 5 gigahertz BYOD clients? It would certainly help out the modern clients that support that band. So, all right, I think we're right at time and have a few minutes for Q&A.
Thanks, Jim. You know, between the analogies and the emoji use, I think you knocked this out of the park, buddy.
Good stuff.
Thanks.
So a lot of great comments, and I got a lot of folks requesting the slide deck from today so they could use it internally. So well done there on content. And I'm going through here and looking for specific questions. I don't know if Heather, you can help me with these if you see any in particular.
We've got one from Brian. What about Chromebooks specifically? Terrible problems.
Good question about Chromebooks. If that's one where you want to do, like I mentioned before, a hands-on evaluation of those, I've done that myself with Chromebooks. There's a real, you know, some of those are built to be as cheap as possible. That's where you're going to find those 2.4 gigahertz only 802.11n adapters, and that's just not going to work at all in a high density environment. So look for ones that are 802.11ac, so they support 5 gigahertz, and start there. Make sure they have their updates all installed, because those will often, with Chrome OS, include driver updates for the adapter too. Mm-hmm. So good question, Brian.
Okay, we've got a couple more coming in here. Bruce asked, do you have advice on cell phone client standardization? To me, that's one of the biggest headaches.
Yeah, I think we're really talking about smartphones and their performance on Wi-Fi, enterprise Wi-Fi networks. It's a challenge because they're really attractive to the organization because you can run apps, you can do a lot of your business processes. It's very convenient, and they go anywhere you are. I would say, Bruce, try and get involved early when there's interest in those, and get, you know, senior leadership to understand how important it is to standardize on a platform. What you don't want is iPhones and 6 different Android phones all in use. Sometimes that's unavoidable, but you want to limit the diversity as much as possible to a few standardized and blessed configurations. So get involved early in those conversations whenever possible.
See one from David in here. Would you recommend enabling DFS in an entire hospital if all devices support DFC?
I would recommend enabling DFS. It's a good idea to test it. Test the channels that you intend to use with like a lab AP. Maybe put it up on one of the highest floors where those radar signatures might be the most likely to affect you, and just go channel by channel and see if there's any DFS events. But the DFS band, that's 2/3 of the spectrum in 5 gigahertz. So you're giving up a huge amount of capacity that most hospitals can really use by not using it. So I do recommend using it. There are some special considerations for voice over Wi-Fi clients. So if you have those, check with the vendor about what their take is and recommendations are for using DFS with those clients too.
And David did drop in another note in here. They are using Zebra TC52s there, so that for those of you who are using those devices in your environments, that's good advice. Maybe one more question here, and then we'll turn it over to Eric. Any extra tips for Macs that temporarily drop off Wi-Fi or audio-video lags? How
Yeah.
do you tell people that their Macs don't perform well? Yeah, that's a good question. As a Mac user, right? Nobody wants to hear that.
Well, I'm a Mac user and I accept that my Mac has roaming problems. Yeah, that's a challenge. One thing you can do to make the case is do over-the-air packet captures, and that kind of shows you what the client's doing, what the AP is doing, and who's dropping the ball. But I think maybe maybe we should refer this one to Eric in our 7 minutes of 7 signal here to show what Mobileye can do to help out with that too, because that's something that's definitely right up our alley.